Alright, we're talking about angles formed by secants and tangents today. I got a couple of quick review questions right here. Finding what x is on this problem. X is a central angle. There's a total of 360 degrees in a circle. That's been split into two parts here, but those got to add up to 360. So if one part is 200, then I know that the other part is 160. So this arc right here is 160 degrees. And we learned that the central angle is the same number of degrees as its intercepted arc. So if that's 160, so is that central angle. On example 2, we have an example of an inscribed angle. The vertex is not at the center of the circle, the vertex is on the circle. And for an inscribed circle, we learned that it is equal to half of its intercepted arc. So first we need to figure out what the intercepted arc is. Well, again, there are 360 degrees in a circle. In this circle, it's been broken up into three parts. 1, 2, 3. But those three parts got to add up to 360. So if I got 140 and 170, that's a total of 310. I can subtract that from 360, and I find out that this arc right here is 50 degrees. Now again, we're trying to find this inscribed angle, and remember the inscribed angle is half of the intercepted arc. So half of 50 is 25. Alright, so those are the two quick review problems. Let's get into the new information. We're doing angles formed by secants and tangents. So here's our first theorem. If a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is half the measure of its intercepted arc. So right here, remember that a tangent is a line that intersects a circle at one point. So this is the tangent intersecting the circle at this point right here. And that point that the tangent intersects the circle at is called the point of tangency. And then remember that a secant is a line that intersects a circle at 2 points. So this is the secant. It's intersecting the circle at these 2 points. Alright, the theorem says that that angle created by the tangent and the secant intersecting at the point of tangency, that is half of its intercepted arc. Well, if this angle is half of the intercepted arc, that means the intercepted arc is twice the size of the angle. So if that's 30, then that intercepted arc must be 60, because 30 is half of 60. Alright, let's turn the page. Alright, let's see if we can do that again. Again, when we're trying to find the value of x here, you should notice we have a tangent and we have a secant. And they are intersecting at the point of tangency. So that theorem we just learned applies. That angle created should be half of the intercepted arc. Alright, so if this is half the intercepted arc is twice as big as that angle. So if I want to set up an equation, that 11x plus 2 should be equal to twice as much as that. So I just need to figure out what is 2 times 89. So 2 times 89 is 178. So I know this arc has to be 178 degrees. So I set that expression equal to 178. And then it's just solving an equation from there, just using our algebra skills. X is being multiplied by 11, so we divide by 11. And you should get 16. X has to be 16 to make sure that that arc is twice as big as that angle created by the secant and tangent. Alright, let's learn another theorem. If two secants intersect in the interior of a circle, then the measure of the angle formed is half the sum of the measures of the arcs intercepted by the angle and its vertical angle. Now that can be a lot to take in just reading it through one time. But notice in this picture we have a secant here intersecting the circle at 2 points. And we have a secant here intersecting the circle at 2 points. So we have two secants and they're intersecting on the interior of the circle. They're intersecting inside that circle. Alright, anytime that happens, the measure of the angle formed, so x is an angle formed by those two, it's half the sum of the intercepted arcs created by the angle and its vertical angle. So this angle is vertical with this angle. Each of those angles have an intercepted arc. This angle has an intercepted arc of 70. This vertical angle has an intercepted arc of 30. Well, that angle is half the sum of those two intercepted arcs. Sum means we're going to add. So a 100 is the sum of the intercepted arcs, and it's half of the sum. So half of 100 is 50. So I know that each of these angles is 50 degrees. Remember, vertical angles are congruent to each other. So that x is 50, according to that theorem. All right, let's check out one more theorem. If two secants, a secant and a tangent, or two tangents intersect in the exterior of a circle, then the measure of the angle formed is half the positive difference of the measures of the intercepted arcs. Okay, so you got three different possible scenarios here where this theorem would apply to. On this example, this is a tangent. It's intersecting the circle at one point. This is a tangent intersecting the circle at one point. Two tangents intersecting in the exterior of a circle is one of those three possible conditions where this theorem applies. So two tangents intersecting at a point exterior. It's on the outside of the circle. Anytime that happens, there are two intercepted arcs here. There's this arc, and then there is this arc. That angle right here is going to be half of the difference between these two. And we say the positive difference because it didn't specify the order that you should use them when you're subtracting. And so depending on which order you put it in, one would come out positive, one would come out negative. It wants the positive number. Obviously, this angle is not going to have a negative measurement. It's impossible for an angle to have a negative something degrees measurement. If you are measuring angles with a protractor, you will not see any negative numbers on there because it's not possible. So first off, there are 360 degrees in a full circle. This circle has been split into two parts. Those two parts should add up to 360. So 360 minus 150 is 210. So I know that this green arc right here is 210 degrees. Well, this angle is half the difference between these two. Difference means difference implies that we subtract. So if I take 210, you just always take the biggest one and subtract the smaller one, you'll end up with a positive number. Subtract 150, you will get 60. So there is the difference between the two intercepted arcs. Remember, we only want half of the difference between the intercepted arcs. So half of 60 is 30. So I know that this angle has to be 30 degrees. All right, we got two more problems. I told you that situation, that theorem applied to three different types of situations. So here was another one of them. We have a tangent and a secant intersecting at 2 points. The tangent and secant are intersecting on the exterior of the circle. So anytime that happens, that angle is going to be half the difference of these two arcs. Well, the arcs are 70 and 150. So let's find the difference. Difference again implies that we subtract. So the difference between those two arcs is 80 degrees, and we want half the difference. So we're going to do half of 80, and half of 80 is 40. So I know x is 40. That angle is 40 degrees. Half the difference of the two intercepted arcs. Sorry, part of that was off the screen for just a second there. All right, we got one more, and we're going to beef it up a little bit with some algebra. We're making these expressions instead of just numbers. But you should see a tangent. It's intersecting the circle at 1 point. Secant intersecting the circle at 2 points. And that tangent and secant are intersecting at a point on the exterior of the circle. So that theorem applies. That angle that's created is going to be half of the difference between these two intercepted arcs. All right, so remember, difference means it implies we subtract. So we're taking that 4x plus 5 and we're subtracting 50. That would give us the difference between these two. Now this angle is only half of that. It's only half of that. So if you want to set an equation up and you got a half and you got a whole, well, it takes two halves to equal a whole. So I need to double this. I'm going to double that x plus 25. If this is only half of this difference, I need 2 halves to equal that whole. So now there's an equation I can use to solve for x. So the first thing I'm going to do, on this side I'm going to combine like terms. 5 minus 50 is a negative 45. On this side I can simplify by distributing 2 times x and 2 times 25. Okay, can't have the variable on both sides of the equation, so I'm going to subtract 2x to get rid of it on this side. So 4x minus 2x is 2x. I got rid of those x's. Continuing, now I want to try to get x by itself. So I want to get rid of that 45. It was being subtracted, so I'm going to do the opposite, and I'm going to add it. Got rid of that 45. All I have left is 2x. Over here, 50 plus 45 is a 95. And then x is being multiplied by 2, so we divide by 2. And x would have to be 47.5 to make sure that that angle is half of the difference between these two intercepted arcs.